Hello class. Today we're going to look at a special log called the common log. And common log just simply refers to a logarithm with base 10. All right. So we like base 10 just because it's our natural way of counting things. We like to count things in 10. So let's see how we navigate around base 10 in log. So normally if we had any base, we would write out the base. So it's like, for example, if I'm working in base 2, I write log of base 2 to the x, and that's my function. All right. In base 10, you could equally write log of base 10 of x equal to f of x. But because log base 10 is our counting number, and we know more about base 10 than any of the other bases, we tend to write a log with base 10 without the base. So when you see a log with the base omitted, like log x, we are universally going to agree that a log without a base refers to a base 10. All right, so you can clearly see that if I said, what is log 10? Then you're going to ask yourself, what is that invisible base over here? That invisible base is base 10. So you're asking yourself, to what power should I raise base 10 to give me 10? You can clearly see this is going to be equal to 1. Likewise, if I gave you log of 100, well, you're asking yourself, to what power should I raise that invisible base, which is 10, to give me 100? That is what? That is going to be 2. If I keep going down, you can see how things are relatable to us in base 10. Like to count in base 10, multiplying 10 divided by 10. It's much cleaner in base 10 than any of the other bases. All right, well, what if I ask you to do log 50? So log 50 is like, you ask yourself, to what power should you raise 10 to give you 50? It's not so clear. So if I try to really solve this, I'm going to set this to x. And remember, a log returns back to us an exponent. So I'm saying log 50 is equal to x. If I switch it to exponent, is that going to be something useful to me? So if I switch it back to exponent, I get 10 to the x is equal to 50. Well, in this case, it didn't really help me. So we have access to a calculator. In your calculator, you have a little button that has log on it. And that is a go-to that we can have when we're trying to solve things that are not so clear in base 10. All right, later on, we'll find other ways to solve this. But for now, you can use your calculator to solve it out and see what you get. All right, and I think your calculator allows you to put in, it has the log feature with the little base and then a little space to put in your argument. So with the common log, all the things that we've been learning is still applicable. All right, so let's look at some 3 examples that go through all the different things that we've done so far. So if you look at log 1,000, to solve this, I can set this equal to x, or I can intuitively see that, oh, the base is 10. So I'm asking myself, to what power should I raise 10 to give me 1,000? You can clearly see that's what? That's 3. And then we have find the domain of log 3x plus 5 minus 3. Again, if you review the notes on how to find domains, the same thing applies here. We are going to look to the argument and make sure that that's greater than what? Greater than 0. So over here, I'm going to get 3x plus 5 is greater than 0. So we end up with 3x is greater than negative 5. X is greater than negative 5 over 3. So my domain is negative 5 over 3 to what? Positive infinity. Now let's look at the last set of questions, and then we will sketch the graph of log base 10. All right, so one of the properties in logs was, if you have a base raised to the log of the same base of an argument, then the output is just the argument. If you have log 10 raised to 10 of 10 raised to the 5, well, to what power should I raise 10 to give me 10 to the 5? That is still 5. And then over here, I'm asking myself, to what power should I raise 10 to give me 1? Clearly, that is what? That's 0. So let's look at the graph of log, because now that we know common log, hey, we can do its transformations too, right? So the first point is always going to pass through 1, 0. And for me to get the next clean point, that's 100. That's when this is what? That's 1. So remember that we said that the bigger the base, the closer it is to the what? To the x-axis. So this is going to look like something like that. Oopsie. It's going to look like something like this. And then it's going to try and do that. So it's kind of close to the x-axis. And don't forget, you get your vertical asymptote at x equal to 0. So this is log x, right, is equal to f of x. And clearly, we could do transformations about it. So as long as you see a log without the base, know that it's what? It's in base 10, and that's what we call the common log. Okay.